Hello, and welcome. Today, we're breaking down a critical part of project management, scheduling resources and costs. We'll turn a theoretical project plan into a realistic master plan. Imagine you have a perfect project network. You know all the tasks and their dependencies. But is it a schedule?
Not yet.
A project network is not a schedule until resources have been assigned. And your cost estimates? They're just a list of numbers until they have been time-phased into a budget. This is the core challenge, moving from a simple plan to a master plan by realistically scheduling our two most important assets, our people and our money. When it comes to managing resources, we have two primary strategies, and the one you choose depends entirely on your situation. First, there's resource smoothing, also called leveling. Think of this as fine-tuning. It's for when you have adequate resources, and you're simply trying to even out the demand by using the available slack in non-critical activities. But what if you don't have enough resources? That brings us to resource-constrained scheduling. In this case, the lack of resources is the driving constraint, and you'll likely have to delay some activities, which can increase the project's overall duration. So how do you choose? You need to classify your project. Is it time-constrained? This means it must be completed by an imposed date. Here, time is your fixed point, and you'll need to be flexible with resources, maybe even adding more to meet the deadline. Or, is it resource-constrained? This means the level of resources you have cannot be exceeded. In this scenario, your resources are the fixed point, and your timeline must be flexible. The project will take as long as it takes with the team you have. Let's say your project is resource-constrained. How do you decide which tasks get priority? You use a technique called the parallel method. This is an iterative process where you schedule your project period by period, applying simple rules of thumb or heuristics to prioritize which activities get the limited resources. The most common heuristics are: first, schedule the activities with the minimum slack. If there's a tie, choose the one with the smallest duration. And if there's still a tie, you can default to the one with the lowest activity ID number. It's important to understand that applying these constraints isn't a free lunch. It has real impacts on your project. First, it reduces your flexibility by using up the slack you once had. This, in turn, increases the number of critical activities. In fact, the traditional critical path you calculated at the beginning may no longer be meaningful. You might even find that activities you plan to run in parallel now have to be done sequentially, one after the other. Now, once your resource schedule is locked in, you can finally build a realistic budget. This is done by creating a time-phased budget. You distribute the costs for labor and materials across the project timeline, showing exactly when you expect to spend the money. The result is the single most important metric for tracking performance: the project cost baseline, also known as plan value or PV. Without this baseline, your financial data is meaningless. Knowing you've spent $2 million by week 5 tells you nothing unless you know what you plan to spend. For decades, that was the standard way of doing things. But a more modern approach, called Critical Chain Project Management or CCPM, challenges this thinking. CCPM argues that the biggest constraint on a project isn't just the tasks, it's the availability of resources. The critical chain, therefore, is the longest path through the project when you consider both task dependencies and resource constraints. It's based on the theory of constraints, which states that to achieve a goal, you must focus all your effort on eliminating the single biggest obstacle. So, how does CCPM work in practice? It flips traditional scheduling on its head. First, it assumes that most task estimates are padded with safety time. CCPM strips this padding out, reducing estimates to their 50-50 likelihood, and pools all that saved time into shared buffers. Instead of managing tasks, the project manager's job is to manage the buffers. There are 3 kinds. A project buffer is a single block of time at the end of the project to protect the final due date. Feeder buffers are placed where non-critical paths merge into the critical chain, protecting it from delays. And resource buffers are not time, but signals that warn a critical resource that they will be needed soon. So, let's wrap up with the key takeaways. First, a project plan only becomes a realistic schedule after you've assigned resources and created a time-phased budget. Second, You must determine if your project is time-constrained, where you level resources, or resource-constrained, where you must delay tasks. Third, this resource schedule allows you to create your planned value baseline, which is essential for tracking cost performance. And finally, Critical Chain Project Management offers a powerful alternative that focuses on managing shared project buffers instead of individual task deadlines. Thanks for watching. By mastering these concepts, you can create schedules that are not just optimistic plans, but realistic roadmaps to success.